is our final working prototype. Our sound was produced through the phone via a website called onlinetonegenerator.com. The sound produced utilized optimized values determined by our experiments. These factors include amplitude, frequency, and quality of sound source.
This is our final working prototype. This one is characterized by its unique and optimized features, which include a circular shape of the waveguide in the largest possible volume that this shape can account for.
As seen, our acoustic horn only allows for minimal loss in sound intensity at a distance of 1 meter from the source of the sound. However, for demonstration purposes, we are not able to use the optimized amplitude value as it will not be able to be captured in the video.
In order to have the minimal loss of sound at a distance of 1 meter away from the source of sound, we had to do 5 individual design experiments which provided us with the optimal features for our horn and the type of sound from the source.
My individual parameter was the quality of sound produced. Hence, I tested 6 different sound qualities, namely sine, square, triangle, sawtooth, violin, and impulse waves. I set up 3 phones. Phone A is the sound producer, phone B records the initial sound intensity, and phone C records the final sound intensity. Phone C is at a distance of 1 meter away from phone A. I calculated the percentage loss in intensity for each of the sound qualities. From my experiment, I can conclude that the sine wave is the most optimal waveform for reducing the loss in sound intensity.
For my variable, which was amplitude, I played the sound at 8 different volumes into a prototype cardboard horn, since I had not possessed the 3D printed horn yet. I kept other sound variables like frequency and quality of sound source constant, and this meant that only amplitude was varied. By recording down the decibels of the sound produced and the sound received 1 meters away through the help of the app Decibel X on my phone, I was able to substitute these values into an equation. I concluded that the lower the amplitude, the lesser the sound intensity loss 1 meter away from the source.
My variable was the frequency of the sound source. Before experimenting, I took some steps to ensure that only frequency and sound intensity are changing. For instance, I conducted the experiments in a quiet environment at night to reduce excessive background noise, and I used the same phone throughout the experiment, just to name a few. I set up the apparatus as shown below here. Firstly, I placed my sound generator set at 800 Hz at 0 cm. Then, I placed my sound detector next to the sound generator. I record down the amplitude and the sound intensity of the sound. I placed my sound detector 100 cm away from the sound source and record the amplitude and the intensity of the sound. I repeated these steps, increasing the frequency by 100 Hz for 8 times. In conclusion, frequencies at 800 Hz to 1000 Hz proved to be the most optimal frequency for loss of sound intensity.
The variable I was in charge of was the volume of air in the horn. Thus, I made 8 horns of varying volume from 1 cm3 to 91.125 cm3. I set up the sound source exactly 1 meter away from the sound receiver and proceeded to play a sound from the sound source without any horn and recorded the sound intensity in decibels. Afterwards, I started attaching the horns onto the sound source and recorded how the horns would affect the sound intensity. After repeating this experiment and tabulating the results, I can conclude that having the largest volume of air in the horn is the most effective option.
My assigned variable was the shape of the waveguide of the horn. Hence, I made 6 different horns with similar volume but different waveguide shapes. I then set up my sound source 1 meter away from my receiver, and I measured the initial volume of the background noise. And then I propped up my horn in front of the speaker of my sound source, and I measured the final volume of the sound in decibels. Through my experiment, I can conclude that the circular horn is the best and most effective option.
In conclusion, when we tested our prototype with the sound source producing a sine wave at a frequency of 800 Hz and with the smallest volume possible, our results gave a very minimal loss in sound intensity. Hence, we achieved the objective of this performance task to a large extent.